Hello guys, I'm GT. Let's continue with numerical integration part 3, Simpson's one-third rule today. So here is Simpson's one-third rule, and different from a trapezoidal rule, Simpson's one-third rule, we are using quadratic function to approximate the area under curve. So this method is exact when y is a 2-degree polynomial. It's a second-degree polynomial. So let's do some revision on degree of polynomial. Okay, so degree of polynomial, if I say y is one first-degree polynomial or 1-degree polynomial, meaning that the maximum index of x in y is 1. Okay, so you can see that all the x here, the maximum is index 1. So if I say it is second degree of polynomial, so meaning that the maximum index of x is 2. Okay, so this is exact for when x is in the power of 2 maximum. Okay, so you can see that this is a graph, and then the boundary is given by a and b, and then we choose a midpoint of a graph, and then this midpoint is denoted as m. So we got x1, x2, x3, a series of x, and a, m, b. So m is the midpoint, so m is a plus b divided by 2. Okay, so this approximate area under curve, the formula is given by this. If you guys would like to see the proof of Simpson's one-third rule, you guys can scroll to the last part of this video. Okay, so let's move on to an example. So using Simpson's one-third rule, n equals to 2, and given this integration, find the area under curve. Okay, so first you calculate the m using a formula and delta x. So you got both equals to 1, and then you plug the delta x inside, the a, m, b inside. So now you got this, and then you just plug in the values according to function. So here the fx is what? X squared. So you just plug it here. So you got this. Okay, and then you got this equals to 2.664. But then note that this fx is in the degree of 2. So let's check if it is exact. So you do the normal integration. You found out that this is also 8 over 3, which is 2.667. Okay, so we can conclude that Simpson's one-third rule is exact when y or fx is in a degree of 2. Okay, so let's move on to the second example. Now the function is this one. Find the area under curve. So as usual, first step, find m. Second step, find delta x. Third step, plug it inside. Fourth step, you just plug in according to fx. So in this case, fx, what is fx? Fx is square root x. So you just plug it there. Fourth step. Okay, and then you got this is 3.4475. so if you do the integration, you find that this is 3.4477. so it's a little bit different. That's why we call this as approximate area under curve. Okay, so here comes the proof of Simpson's one-third rule. So if you are given this, and then the function that you want to calculate the area under curve is fx, so the approximate area under curve, we denote it as gx. So note that gx is a quadratic function, and then we don't know the coefficients of a quadratic function, so let's put it as k0, k1, and kx. Okay, it is a series of k of coefficients. Okay, so we know that m is a midpoint, so m equals to m a plus b over 2. Okay, so what's the first step? Since you know that there's 3 unknowns here, k0, k1, k2, So we need 3 equations to solve this function, right? So what we're gonna do is, we have 3 points here. So we just sub it, these 3 points, into gx. So when x equals to a, m, b, you got these 3 equations. Just sub it inside. So when you have 3 equations, 3 unknowns, what you're gonna do? You're gonna solve this system of equation using matrix. So this is a matrix formula, solving a system of equation. If you guys don't know this, I might do one video about it, okay? But just keep in mind that this is solving a matrix of system of equation, okay? So if you got this, move it to the 3rd point. You solve this system of equation, we will get k0, k1, and k2 in this form. If you simplify the matrix, you will get k0, k1, and k2. So if you got k1, k0, k1, and k2, what is the next step? You find the approximate area under curve using an integration. So what we gonna find is the approximate area of fx. So this is the area under curve of gx, while gx is given by this. So you do the integration with respect to gx. So you got this and the limit of b, a to b, okay? So you just sub a to b inside and simplify. What you got? You got this. And then when you got this, since all of them are in terms of b and a, and you got k0, k1, k2 in terms of a and b in the 3rd step, so you just sub the one that we got here inside. So you sub it inside this and you simplify, you got this. But then note that delta x is b minus a over 2. So you can factorize this out. So you got delta x over 3 equals to this. Thank you for watching. If you all would like to see more math and engineering mathematics video in the future, hit the subscribe button. See you all next time.